See, good morning. So today I shall give you a revision of from the uh, means chapter one. We can say that is the first one is your statics of particle, right? Statics of particle. So here, what are the things are there? One is force. So to know first the vector. In vector, for this chapter one in statics of particle, here one concept is need, that is the force vector. In force vector, actually, if we define, two things are there. One is we can define the force vector as F, that is in the bold. By this manner we can say what the force is a vector, or we can write F arrow. This is, or this is anyone, but this is normally not possible to write in exam, means any copy. So that's why we normally follow the F and arrow. Okay, this is the force vector. In means, what is the force vector? If we say, what does it means? It means that the magnitude of force into the unit vector of that force line of action, the line of action of that force. Okay, the line of action of that force system. Now next part which will come, that is the resolution of forces of. In the resolution of forces, it means, suppose you have one force vector which is, for example, applied on a body. Okay, if we apply a force vector, and suppose you apply another force here, suppose this is F2. Okay, this is F1. So what should be the resultant force which is acted on this body? It means the summation of two force vector. It means, how we can define that one? We can define that, remember one thing, that when we apply this arrow na, this arrow length, the length of the arrow indicates the magnitude of that force, means this one, that length of that arrow, and the arrow head indicates the direction. Okay, arrowhead indicates the direction, and length of that arrow is the magnitude of that force. So what should be the resultant? Just simply R is equal to F1 plus F2, right? That is the resultant of two forces. And if there, suppose in question it is written like that, resolute of force system, means suppose a force is given at an angle of 30 degree, and it is said that how much vertical force is acted on that force, or how much horizontal force is acted on the system. So you have to resolute that to, means that forces into two component, one is along the horizontal and one is along the vertical. So that should be, suppose if it is F, so F cos 30, and this one is F sin 30. Okay, so that two force, this is the resolution of force. And normal, generally we have write this one in such a manner that if it is your resultant, and if it is your we resolute that force, then we can write, suppose this is P, this is Q, then we can write R is equal to P plus Q. Okay. Similarly, they also have the addition of two vector, they also have the subtraction of two vector. What happened? Please tell to your friends that join as soon as possible. Different time they come, it is problematic for me. Okay. See, so up to this means r is equal to p plus q. Now if we write any I already told you now that this is your force vector. So force vector, suppose again, of, suppose the force vector you have, and if you want to define that force vector into the coordinate system, means if, and this is your x, this is your y, this is your z. Okay, in 2D system, suppose in 2D system you have to define any force vector. How you can define? You can define a force vector as fx of I plus fy of j. Here remember, this fx is the magnitude of the force along x, and this is the magnitude of force along y. Remember, these two are the magnitude. Okay, this is a scalar quantity, but when this force we define with the arrow, it indicates the vector quantity, because it also indicates the directions. Okay, magnitudes and the directions both. Clear? And here I and j are the unit vector. In such a manner we identify, or we can find out any force vector. Hmm? Next part is, suppose it is there, and you have to find in the question, suppose it is written such that you have to find out the angle at which it will act, suppose. Then how you can define that one? It is very simple. Only you have to write the tan theta is equal to fy by fx. Okay, for which case I already show you here na, that if it is, suppose this is your force which is acted here, and if it is perpendicular is cos 30, horizontal one is the sin 30. So how much angle it was? Suppose in the question it is not given, you have to find out this angle. Then suppose in the question it is given that only force vector. Okay, so you have to first resolve that two force into the component, and then how can you find out this theta? Na, just fy and fx. Clear? So in such a manner you can find out the theta. Next part is, this is the 2D system na? Now come to the 3D system. 3D system, what happened here? You know, in the 3D system, in the, if we consider the Cartesian coordinate system, then you know that one is, we, see here, this is x, this is y, this is z. So this is the Cartesian coordinate system, and in this coordinate system, suppose you have to find out, you have to define fx. So fx means when that force is along the, in this direction. Hmm. And if y means, see, this is your fx, this is your fy. And you have to find out that how much of fx create if there have any, your internet connection is suppose a force vector which is come from this origin O, and suppose it will come into the opposite side of that hexagonal cube, right? So if it is your resultant, we can define into the along the three axis now, we can resolute that force. So what can we write? Fx, we can write the fx is equal to f cos theta x. It means the angle which is created here. Okay, that is theta x. The angle which is created here, that is theta y, and the angle which is created here, that is theta z. So similarly, f y is nothing but f cos theta y, and f z is equal to f cos theta z. Okay, and in a 3D system similar to the 2D system, the resultant force vector is nothing but fxi plus fyj plus fz of k. Okay, these are the unit vector, and we can put here instead of f, we can easily put here if instead of fx, f cos theta x of I plus f cos theta y of y plus f cos theta z of k. Clear? So what can we get? If it is, then we can say that the lambda is the unit vector of this force vector. So we can write that is nothing but the cos theta x plus cos theta y of j cos theta z of k. This is I. This is your unit vector of this force system, right? Now from there you can easily write, means this is a vector form, that is the cos square theta x plus cos square theta y plus cos square theta z is equal to 1. Okay, this is the equation. And you all know if vector is equal to, f vector is equal to f cos theta, means this one, if vector is equal to fxi, fyj, fz. So to find out the magnitude of that force vector, we can write f is equal to root over of all three component of the scalar quantity. Now, these all are the scalar quantity in the direction of x, y, z. So root over of all their square, we can get the magnitude. This is the magnitude of force. Now suppose in question find out the theta. How you can find out the theta? Cos theta x is nothing but fx by f, means from here you can easily write na this one, fx by f cos theta x, fy by y cos theta y, fz by f cos theta z. Up to this, anyone have any question? This is the simple force system on any particle. Any question up to this? See, from here one numerical problem may come in the exam, so be clear your concept here. Okay, so up to this, is it clear? Anyone have any confusion?
Clear, sir.
Okay, okay. See, so up to this is the force system. Na? Next, what will come? Then will come the, for any rigid body, this is the equivalent system of forces. Suppose, I already told you one thing, na, that is the space vector. Space vector means, suppose a body is there, and uh, you apply a force here. अरे बाप रे, नवीन sir. And suppose a force which is acted here. Hmm. How, when we can say this is force space vector, when this force goes through a line of action and you can apply a force here. For example, means you can write it like this. Suppose here it is, and same line of action, another force is there. If it is F1, if it is F2, but both are same in magnitude, same in direction, then we can say these are the space vectors. Means, and though it is applied here in the different position of that body, though it is applied in the different position of that body, but there, due to this force, what about the happening within the system, that is are same, the effect are same. Hmm. So that we call the space vector. Okay, now come to the moment. So have you remember what is the moment? You normally know the moment is nothing but the force into distance, right? But here, to write down in the vectorial notation, what we have to write, moment is, yeah, itself a vector, and that is nothing but the cross product of the force and their distance, whatever position vector. It is not the perpendicular distance. Now normally you know that moment is the force into perpendicular distance, but here in case of vectorial notation, if you want to write that, the any position vector, the cross product with the amount of force which is applied on that system is create a moment. Okay, and if I show you in the graphical manner, then you can find out, suppose a object is there, for example, and on that object, suppose here that force is acted, and suppose if is a vector which is denoted as, for example, 2i plus 3j plus 4k, for example. And suppose this position is a, and a is denoted as, position of a is what can I write, along x it is 4, along y it is 3, along z it is 2, for example. That is the position of that point. So in terms of position vector, how we can write, see, from this origin, that is 0 0 0 to here, we can write it is r of, see, from where to where it is come, o to a, right? Means from o to a. So r of o to a minus position vector of ro, and you know this is a 0 0 0 coordinate, so ro here for this case, ro is nothing but the 0. So we have to, why you join now? So ra, so ra means a, you know this is the position, so you can write 4i plus 3j plus 2k, right? These are the position vector of ra. So we can write as, this is one is a 0, this is a 0 0 0 coordinate, for that reason. So roa is the this one, and the force is given, for example, like this. Then to find out the moment, what you have to do, simply cross product, means ijk, r is 4 3 2, and 2 3 4 is the f. Okay, r cross f. So from here you get some ijk component, so that is the moment. So up to this, is it clear?
Yes, sir.
Okay, next part which will come, that is the which force of a system resultant, also discuss. Okay, next come to another topic, that is, you all know the moment. This is the with respect, when I find out means when I calculate this one, that is the with respect to any origin, right? Now suppose it is said with respect to any another point. Suppose in the question it is written like that, this is your force, and here for the present case you have find out already moment about the O point, right? Now suppose in the question it is written like that, with respect to x axis you have to find out how much moment it will generate due to this acted force F. So then how you can find out this one? In that case, if we suppose it is said with respect to x, na, you have to simply multiply, means after finding this mo you have to simply do the dot product. What you have to do, mx is you got here, uh, 16i, for example, you just do yourself. I am just giving a simple example for the present case. 10j plus 8k, for example. So what you have to do, 16i you got and dot I, so the magnitude of the moment along x is 16 newton meter. Okay, in such a manner you have to find out the force with respect to any axis. Hmm. Now suppose, what can I say, suppose this is your xyz, na. Suppose they said in the with respect to any another axis, suppose this is a axis, with respect to this axis you have to find out the moment. So how you can find out? You have to simply first remember, you have to find out first the unit vector, which means we can generally define it as a lambda unit vector of that axis, then multiply, or we can say this is a dot product of dot product with m with respect to origin, we can find out the moment with respect to any arbitrary axis. So which is normally we can write in such a manner, m any arbitrary, if we say arbitrary, it is nothing but m lambda vector unit vector into m0. So we can write r cross f. In such a manner we can also write this thing. Now come to the another topic, that is the couple. So what is the couple? Suppose this is your body, a force which is acted here, and as per the statics, we consider all the bodies are the here as a rigid. So remember one thing, if a body is rigid, then that space vector concept is applied here. So what happened now, that force if we applied here, we can say this is the same thing which is also applied in this system. Within the within this direction that force will move. So if suppose another force will also act in this opposite direction, then this will create a moment. And this one we can say, if they have a opposite in direction and same in magnitude. Suppose this is f1 vector, this is f2 vector. If f1 and f2 are parallel, this is one condition. And f1, this may be come in the exam, that for which condition we can say this moment is a couple. Okay, and their magnitude is also equal. If these two conditions satisfied, then we can say this is a couple. Now the case is, which one is the direction of that couple? So we have to apply the right hand thumbs rule. here you can see that the thumb is in the upward direction. If we consider our all other four fingers move along the anti-clockwise direction, right, then it is up. So it means if it is anti-clockwise direction, then it will come out from this surface, means the perpendicular of that. I think you can understand. If it is your plane, from that plane the perpendicular, if it is in the anti-clockwise direction, and if it is clockwise direction, it means it is the uh, opposite side of, it is also perpendicular direction, but that is on the opposite direction. Okay, now come another topic, that is we can write here, suppose you have the moment with you, but you have to move that moment with a different point. So how to do that? Suppose this is your system and you already applied two parallel force and equal in magnitude, and what you can write here, that is xy0, you can draw similar type of figure, that is this one na? You can see this will create an anti-clockwise moment. It means the direction of that moment is the perpendicular in the upward direction, right? So if it is m, then if we can move this one, this is as already told, that is any space vector we can move, making this thing in the parallel. So we can write this thing, the direction and the angle, both should be similar. So this one and this one give of same magnitude and the direction, it will provide the same thing. And if we resolute that moment, suppose this is a resultant, if we resolute, then we can easily resolute that moment, means just write in term of mx, my, and mz, means if it is a resultant, so that nothing but, if it is resultant moment vector, nothing but mx of I, mx, my of j plus mz of k. These all are the magnitude, and from cos theta we can write mx by, similarly other for others also, theta x, cos theta x it is. And I think I have already give you a lot of numerical examples na, during my lecture schedule. So just go through that numerical problems, and if anyone find any type of problem, no issue, means conceptual problem if it is there. See Krishna Veni, now he or she joined. See, uh, okay, let's solve one problem. Suppose, anyone want to say anything in based on this 3D system na, I can solve one problem. Suppose here this is a 3D cubic system. Okay, and suppose one force which is acted here and another force which is acted in this direction. Suppose two forces are acted, hmm, and they have the, for example, same in magnitude. Consider the magnitude are same. One is along the x direction, one is along the y direction, and this is a cube. And take this one as a distance of unit, means 1 meter, take it is a 1 meter. Okay, now if they want to find out from this system how much moment will act on any, hello, is my voice is audible, right?
Yes, sir, audible.
Yes, sir.
Okay, okay. So see, Suppose that two vector, which is one is the along the x and one is along the y. So first you have to find out the direction of their resultant force. So how you can find out the resultant force for this? See, 1 meter means this all are the 1 meter. This is a cube, huh? All are 1 meter. Don't confuse with that. All are one. All are 1 meter. So if it is said in the question, find the, what I told, find the resultant, right? Find the resultant or moment with respect to coordinate, means 0, with respect to 0. Suppose this will become. So how you can find out? If there is, remember, if there is no value or magnitude is given, you just simply consider this one as a, f is a vector and f is fxi, fyj and fz of k. Okay, just simply. And as there it is written that the two force vector are same, so you consider if this is also same thing. So just summation of that, so that is the total force resultant which is acted along the, which is acted on this cube, right? Normally I can say normally it is not it is normally given, and if it is given na, then along x direction if it is, then it will give, suppose 4i plus 2j plus 3k, like that. Similarly they also have given in such a manner. So when you have to find out the moment, how can you find out the moment? Simply the cross product. So what you have to do, first find out the position vector. Which position vector you need? See, this is a very tricky thing. Suppose you have to find out this position vector, right? And suppose you have to find, see, two in very, in various way we can solve this thing. Suppose you consider this is your point, and in this point this force will acted, or based on the space vector concept you can consider this force will acted from here, right? And you can find out the position vector of this, and you please try to understand to write the position vector of this point and find out the position vector with respect to O of this point is little bit easy compared to this point position vector with respect to O, right? Do you understand my point? This is the force. See, this is your force. So from space vector concept you can move your force here to here, as their direction are same and as well as their magnitude are same. Keeping both things the same, you just move your force vector position from here to here. So if it is, then to find out the position vector of this is a little bit easier, right? Now next, what we have to do, moment resultant is nothing but one is, you can write if, okay, right, it is at a 1 or 2. So r1 cross f1 plus r2 cross f2, these all are the vector. And here this r1 is nothing but, see, this is your r1, right? So r1 you can write only along O2. If you write is as a B C D E F G, so it is nothing but R of G minus R of O. Now see, R of G is what? R of G is 1 into J, right? R of G, this one, this vector, na? So it is only along the y axis, no along the z axis, and not any magnitude along the x axis, right? So R1 is only 1j. and R0 is 0. Similarly, R2, R2, we can write this one. Na? This one is only along Z. So 1K, 1K only. See, now this force multiplied with this distance. So this is 1K and this force vector we have to find out. So this force for this F2 and F1. Na? So F2 is nothing but, if it is magnitude, this is your vector. So if it is magnitude is F, then if it is multiplied with the along the Y direction, so it is J. So it is F dot J. This is the F2 vector as it is the along this Y direction. So what we have to do now, R1 means M of R is 1 dot J M cross F1 is Fi plus 1 dot K, it is R2 cross F2 is Fj. Okay. Remember these F are the scalar quantity and these are the unit vector. These are the unit vector. This is the length of each side of that cube. And this is the resultant moment which we need to find out. So in such a manner it will come. Clear? Up to this, is it clear? Next day we shall discuss on the four forces acted on any system and the three forces acted on any system, both the planar, coplanar or concurrent, and all the different 3D system forces are there. For all this case, we can solve some numerical problem before that mid-sem exam. Okay. So theoretically concept is okay till now. Anyone have any clarification? You can ask. Hello? Anybody is there? Hello?
Yes, sir.
If anyone have any question, you can ask. Means conceptually, because in exam this type of some problem will come, conceptual problem, very basic problem. And okay, next day also I have to discuss about only 2 class I can get na before mid-sem, and then friction problem also I just recapitulate all this thing, huh? In the next lecture. Okay, thank you.
Okay, sir.
Send me, anyone send me the attendance. Anyone send me the attendance screenshot? Okay, thank you.